sp3 hybrid orbitals are directional because they form by mixing 1 s orbital and 3 p orbitals into 4 equivalent orbitals that point toward the corners of a tetrahedron. And each orbital has one larger lobe that provides stronger overlap with other atoms' orbitals for bonding. Imagine you are building a tent with 4 poles that all lean away from the center in different directions, so the tent is stable. sp3 hybrid orbitals are like those poles pointing toward the corners of a boxy triangle shape called a tetrahedron. So the electrons are held in specific directions rather than all around the atom. When the s orbital and the 3p orbitals combine, they make 4 new orbitals that are shaped unevenly, with one side bigger than the other, and that bigger side is where 2 atoms can meet and share electrons more easily. Stronger overlap happens because the bigger lobe brings electron density closer to the other atom, which makes the shared electron pair between atoms more stable and the bond stronger. That is why carbon with sp3 hybrid orbitals forms single bonds that are held in fixed directions and give molecules their 3-dimensional shapes. A common mistake is thinking the hybrid orbitals are real little balls you can see. They are mathematical shapes that show where electrons are most likely to be. And the tip to avoid this confusion is to focus on how hybridization predicts bond angles and shapes, rather than picturing tiny solid objects. Another misconception is believing the lobes are identical. Remember, one lobe is larger, and the larger lobe is the part that overlaps to form stronger bonds. So when drawing or imagining orbitals, show unequal lobe sizes. Students sometimes mix up hybridization with simple mixing of whole atoms. Keep in mind, hybridization happens within a single atom's orbitals to make bonding more effective with neighbors. For more videos and resources on how orbitals and hybridization work, check out www.gumballdegree.com.